Hello math friends, this is CC3 lesson 321. How can I check my answer? We are on page 122 if you're following along in your book. Otherwise, open up your ebook and take a look. We're going to kind of look at a few different things throughout the lesson and talk about how can I check my answers. So solving equations and checking solutions. In section 2.2, we learned to solve equations on an equation mat. In this section, you will practice your equation solving skills while adding a new element. You will check your answer to make sure it's correct. While solving equations in this lesson, keep these focus questions in mind. What is your goal? How can you get started? How can I simplify, and can I get x alone? All right, so we're going to pop over and just take a look and talk about number 70, but then we're really going to focus on number 72 and solving those and making sure we're checking our work. All right, for number 70, for this activity, it says share algebra tiles in an equation mat with a partner. Now, you can do the algebra tile work in your ebook, and down here you can see that there's an e-tool for this. So actually, even though we're not going to go through this together, I would like you to, because everybody has access to their ebook, to click on this e-tool in lesson 321, and it will pop up with this tile mat, and go ahead and work on simplifying that, making sure you're recording the steps that are taken to get from the old equation to the new, and then write the new equation that represents the tiles in the mat. Okay? All right. All right, so this is number 72a, 3x plus 4 equals x plus 8, and let's just go through the steps to simplify this. And again, our goal this time is to make sure that we are checking our work when we're finished. Okay, so there's nothing that I can simplify on each side of the equation. I simply need to start moving the tiles back and forth across the tile mat. And if you're kind of envisioning that this is like, you know, the dotted line of the tile mat, and we can move things back and forth. Okay, so the first thing I think I'm going to do is I'm going to subtract 4 from both sides. But here's another thing I want you to consider. I always try to make sure that at the very end I have a positive coefficient to the variable. So like I want to move things around so that when I move this x over here over, that this is still a positive. This is still a positive number. So I'm always thinking like that when I'm doing that. That's why what I'm going to do first is I'm going to take this 4 and I'm going to move it over to this side, because then that'll allow me to move this x to this side, and I'll have 2x here. Okay, so I'm going to minus 4x from both sides. See, I didn't mean to do that. Oh, for crying out loud. Let me erase this. I'm going to do it right. Minus 4 from both sides, to both sides. Okay, that leaves me with a 0 pair over here on the left side. All I'm left with is 3x equals x plus, and 8 minus 4 is 4. Okay, made a lot of sense. Next we're going to, so that was a CLT. Next we are going to subtract this x and move it to the other side. And I've got 2x equals 4, okay? Minus x to both sides. Now, the last step always when we're solving an equation is to divide away the coefficient. And my coefficient is 2, so I'm going to divide by 2. I'm going to divide by 2. And I know that I'm going to get x equals 2. Okay. Now what I want to do is I'm going to substitute this 2 in up here. And actually I think I've got enough space to kind of just put the 2 in right here and the 2 in right here. And I'm just going to check and make sure my work checks. So now what I have is, and I can rewrite it down here, 3 times 2 plus 4, does that all equal 2 plus 8? Well, 3 times 2 is 6, 6 plus 4 is 10, and does 10 equal 10? Yes, and I'm going to run out of room down here. So this one checks. Check mark means yes, it is correct. All right, let's do another one, maybe a little bit more difficult. All right, still number 72. Now we're working on letter D. Notice that we're working with K for variable. It does not matter what your variable is. It can be any letter, actually. So, okay, first thing I'm going to think about is, you know what, I think I can combine some like terms on both sides. I've got a -2 and a -2 together. That's -4 minus 3k is still there, equals, and then I can do this -2k minus k, which is a -3k plus 8. Okay. Now what I'm going to do is, I think I'm going to, well, this is interesting. What do you think? Because I'm looking at this and I'm looking at the -3k here, and I'm looking at this -3k, and you know what? We could remove a balanced set of -3k, right? Let's do that. We're going to remove a balanced set of -3k. So now all I have here is -4 equals 8. What do you think about that? Can we go any further? See, the thing is, even if we would have done this, let's just pretend we would have gone back to this step. And let's say we would have added 4 to both sides. Let's try something else. Now I've got -3k, because this is a 0 pair and that's gone, equals -3k plus 12. But then if I try to move this 3k to the other side, this -3k, by adding it, guess what happens? I get 0 equals 12. So it doesn't matter. Either way that we do that, we're either going to get -4 equals 8 when we did it the first way, or we get 0 equals 12. But what it means ultimately here is that there is no solution, meaning that no numbers will work for that. Okay, so then of course there's nothing for us to substitute in, because we cannot go any further than that. Let me take a look if there's any more that I want to talk about. Nope, I think that's good. So on to the next lesson.